In question 6, the diagram shows a motif formed by the major arc AB of a circle with radius R and center O, and the minor arc AOB of a circle also with radius R but with center C. The point C lies on the circle with center O. In part A, it's given that angle ACB is equals to K pi radians. State the value of the fraction K. Now it is talking about the angle ACB, so we can first make the angle ACB over here. Now we know that from circle properties that the angle at the center, this angle will be twice of this angle. And as all of these lengths are equal, angle AOB and ACB are equal. So this angle of the major segment and the minor segment, these two angles, we know that they obviously add to 360. So let's say this angle is X, and we know that this angle will be twice of this angle. So if this angle is X, this angle will also be X, and this will be twice of X. So we can write it as 2x plus x will be is equals to 2 pi radians, basically, which is equals to 360. So 3x will be is equals to 2 pi, and the value of x will be 2 upon 3 pi radians. So we can write that the value of k will be is equals to 2 upon 3. In part B, it says state the perimeter of the shaded motif in terms of pi and r. Now we have to find the perimeter, which means we have to find the arc length of AOB. So in the first step, finding the arc length of AOB, we know that the formula for arc length is given as r theta. So the radius is r and theta for the small sector with center C. X is 2 upon 3 pi. X is 2 upon 3. So this will become r multiplied by 2 upon 3 pi radians, and finding the arc length of the major segment AB. So this was AOB sector, and this will become the arc length of AB. So this will become arc length AB, which is basically of the major segment. We know that the radius is R, and as the angle over here is twice of 2 upon 3 pi, so that will become 4 upon 3 pi. Now, once we have these two lengths, we can add them up. So the first length is 2 upon 3 pi, which is basically the length of the smaller sector AOB, and the length of the major sector from the with center O, the length of the arc length AB, that is equals to 4 pi r upon 3. So this will become 2 pi r upon 3 plus 4 pi r upon 3. So this will become 6 pi r upon 3, which we can simplify it and write it as 2 pi r. So the perimeter of the shaded region will be is equals to 2 pi r. In part C, it says find the area of the shaded motif, giving your answer in terms of pi r and root 3. To find the area of the shaded region, now we first will find the area of this major segment. So let's make a line from over here. So first, finding the area of this major segment AOB, we know that the angle is 4 upon 3 pi and the radius is r. So in the first step, we'll find the area of major segment AOB, which will be is equals, the area is given by the formula half r squared theta. We know that the radius is r, so this will be 1 upon 2 r squared, and the angle is 4 upon 3 pi, so this will become 4 upon 3 pi. We can simplify it and write it as 4 pi r squared upon 6. So this will become 4 pi r squared upon 6. Now this part basically consisted of the unshaded region as well. Now to find the area of that unshaded region, so we can subtract it from the total area. We can first find the area of the sector AOB with center C. So we know that the angle x is 2 upon 3 pi. So finding the area of sector AOB, so area of, and we can call this as a minor segment. So area of minor segment or minor sector, basically this is a minor sector over here, AOB. We'll use the formula half r squared theta. So this will be half r squared, and the angle is 2 upon 3 pi. So this will become we can cancel the 2 and this will become pi r squared upon 3. Now from this area, we'll have to subtract the area of these two triangles. So we have the area of the sector. Now we can make it separately over here. So let's say this is AC, this is AB, and this is the point over here. We have the total area over here. Now to find, as there's a as we have made a triangle over here, so we can find the area of one of these triangles multiplied by 2 and subtract it from the total area, which will give us the area of this unshaded part or the region in black. So finding the area of a triangle, we know that the formula for area of a triangle is half AB sine C. The radius is R and the angle is 2 upon 3 pi. So we can write that the area of one triangle will be is equals to, the formula is half AB sine C. So the two lengths will be R and R, so that will become half R squared, and the angle is 2 upon 3 pi. So this will become sine of 2 upon 3 pi. Sine of 2 upon 3 pi, when we substitute this in the calculator, that is equals to root 3 upon 2. So this will become R squared into root 3 upon 2. And this is R squared upon 2. So this will become root 3 R squared upon 4. Multiplying this by 2, as there are two triangles. So the area of two triangles will become 2 multiplied by root 3 R squared upon 4. Simplifying this, we can write it as root 3 R squared upon 2. Now, once we have the area of the two triangles as well, we can subtract it from the area of the minor sector AOB, which was pi r squared upon 3. So pi r squared upon 3 minus root 3 r squared upon 2. Taking the LCM, so the LCM in this case will become 6. So this will multiply by 2. So this will become 2 pi r squared minus, and this will multiply by 3. So this will become 3 root 3 r squared. So this basically is the area of the unshaded part. And once we have this, we can subtract it from the total area of the major segment AOB, which was 4 pi r squared upon 6. So the shaded region will be is equals to, so that was 4 pi r squared upon 6. And we'll subtract it from 2 pi r squared minus 3 root 3 r squared upon 6. Taking the LCM over here, so the LCM will be 6. And this was 4 pi r squared upon 6 over here. So this will be a 6 over here. So 4 pi r squared minus 2 pi r squared. So that will become 2 pi r squared minus minus will make it a positive. So this will become 3 root 3 r squared. We can divide both of these terms by 6 and write it as 2 pi r upon 6 plus 3 upon 6 root 3 r squared. So this will cancel out and this will also cancel out. So the final answer can be written as 1 upon 3, and this is an r squared over here. So this will become 1 upon 3 pi r squared plus root 3 r squared upon 2. So this will be the final area shaded region of the shaded region, which is basically the area of the motif.